Welcome to K-Nearest Neighbors, KNN, in Python. In this lesson, we will learn how to use Python to find patterns and make predictions with a simple but powerful machine learning technique called KNN. You will see how to work with real data, step by step. No experience needed. Running the cell now. First, we will prepare Python to ignore warnings. This keeps things clear. We import Python's warnings library. We will use the warnings module to control alert messages. We tell Python to ignore all warnings. This message shows we are ready. Running the cell now. Try running this cell to make sure your environment is set up. What is KNN? KNN is a way for computers to recognize patterns by comparing things. It asks, what are the most similar examples to this new one? It is useful for classifying things, like sorting emails as spam or not spam. Running the cell now. First, let's warm up with simple math in Python. This comment describes what we are doing in this cell. We create a variable called a and give it the value 9. We create a variable called b and set it to 16. We add a and b together, divide by 2, and store that in a variable called result. This prints the average to the screen. Running the cell now. Try changing the numbers. What happens? Lists help us store many values in one place. Lists use square brackets. This line describes that we are using a Python list. We create a list of numbers. Each item is separated by a comma. We get the first number in the list. Lists start at 0 in Python. We get the last number in the list. -1 means the last item. Running the cell now. Try printing other positions, like numbers, too. How does KNN work? KNN finds the k closest neighbors to any point. It counts which category shows up the most nearby. Then, it guesses that your new data belongs to that category. Running the cell now. KNN depends on comparing distances between points. Let us see how far apart two numbers are. This comment explains what we are doing. We have a number x1. We have another number x2. We use abs to get the absolute difference between the numbers. This means how far they are apart, ignoring negative signs. We show the distance. Running the cell now. Try changing x1 and x2 to see different results. Usually, data has more than one number. Let us try finding the distance when there are two features, like height and weight. This comment reminds us what the code does. We have a list for person A. The first value is height in centimeters. The second is weight in kilograms. We have a list for person B, with height and weight. We subtract B's height from A's height. We subtract B's weight from A's weight. This is called Euclidean distance. It is the straight line between the 2 points, like a ruler laid across the floor. We print out the result. Running the cell now. Try adding your own numbers for 2 people. Let us work with real data. We will use the famous iris flower dataset. We want to predict the species of a flower from some measurements. Running the cell now. Now let us load the real dataset from scikit-learn. We add a comment so we know what this cell does. We load the iris flower dataset with scikit-learn's built-in loader. Now we import pandas to work with tables of data. We tell scikit-learn to give us a pandas data frame for our data. We keep only the data frame part, which acts like a table. We print the shape, showing rows and columns. We preview the start of the data table. Running the cell now. Run this to make sure you see a table of numbers and names. It is good to know how many samples we have for each flower type. We check how many times each category shows up in the target column. This lets us see if our data is balanced. Running the cell now. If one class is much bigger, KNN can have trouble. Machine learning uses some data to learn and some data to test how well it works. This comment explains that we are dividing data into two groups. We import train test split from scikit-learn. X is all the columns except the answer or target. Y is the column called target, our answer. We split X and Y into training and test sets. Test size means we hold back 20% for testing. Random state gives the same result each time. We print the size of the training set. We print the size of the test set. Running the cell now. This split helps measure our model's real skill. Now we use scikit-learn's KNN. Let us make a model and learn from the data. This comment tells us we are building the model. We import the k-neighbors classifier from scikit-learn. We make a new KNN model, asking it to look at 3 neighbors. We fit our model to the training data so it can learn patterns. We let you know the model is ready. Running the cell now. Change the number in n_neighbors and try again to see what changes. Now our model can make predictions. This line reminds us we are ready to predict. We use predict to get model guesses for the test flowers. We print just the first 10 predictions to keep it short. Running the cell now. Predictions are what the model thinks about each flower. We need to know how well our model works. This line says we will check accuracy, which is how many correct predictions we have. We import the accuracy score function from scikit-learn. We ask how many predictions match the right answer. We print the accuracy out of 1.0, so 0.95 means 95%. Running the cell now. This number helps us know if our model is useful. Let us see KNN in action. Enter your own flower measurements to predict a species. This comment explains we will use input to get new data. We start with an empty list for the user's values. We get the names of all the features we need. We go through each feature name. We ask the user to type in a value and turn it into a floating point number. We add the user's number to the list. We predict with our trained KNN model. We show the predicted species name. That is the kind of flower KNN thinks it is. Running the cell now. Try some numbers from the data preview for better predictions. If you learned something, consider subscribing or liking the video. Now let us see what happens when k is too big. This line warns us we are choosing a poor k value. We set k to 100 neighbors, much higher than before. We train the model again with the big K. We predict on the test data. We check the accuracy with our metric. We print the result with the new K value. Running the cell now. Very big K is not usually helpful in KNN. Instead of guessing K, let us try many choices and see which is best. We want to find the best K value, so we will test many options. We start with an empty list for storing accuracy. We try K from 1 up through 15. We make a new model for each possible K. We train the model on the training data. We make predictions for the test data. We check how good the predictions are and save the numbers. We print K values we tested. We print the matching list of accuracy scores. Running the cell now. Pick the K with the highest score. Now let us use KNN to predict the type of several made-up flowers. The comment tells us we are starting a mini project. We make a list of 3 new flowers, each with 4 numbers just like the iris data. We predict the types for all these flowers at once. We repeat once for each result and print the answer. This tells us the predicted species for each new flower. Running the cell now. Try making up your own flower examples in the list. KNN works better if all numbers are on the same scale. Here is a tip. We scale the numbers, so all features have equal weight. We import the standard scaler tool. We make a scaler and fit it on the training data. We use the scaler to convert both training and test data. Now we train a KNN model using the scaled data. We fit the model on scaled features. We get accuracy on the new predictions. We print the accuracy after scaling. Running the cell now. Scaling is often important in data science. Sometimes, our code does not work if we use the wrong number of features. This cell handles mistakes with try and except. We try to predict with too few inputs. This causes an exception because KNN needs 4 features, not 2. If there is a problem, the except block catches and prints it. We show the exact error message. Running the cell now. When you see errors, check your inputs and their shape. Here is a helpful method. Let us see which training data points are closest to a test sample. This comment shows we are finding nearest neighbors directly. We use neighbors to get distances and locations of closest points. We print the distances to the nearest neighbors. We print the index numbers of those neighbors. Running the cell now. You can use this to understand what your model is looking at. Here is your challenge. Use different datasets or change K. This challenge asks you to try something new. We suggest using a different scikit-learn classification dataset with KNN. Or try different values for K and see what happens. Running the cell now. Extra practice helps you learn best. Recap. We introduced KNN and saw how to use it for classification. You learned how to prepare data, train and test a model, tune K, use real-world data. Good job! Running the cell now. Thanks for learning KNN. Try KNN on your own and tell us what you discover. If this lesson helped, like or subscribe for more Python. Running the cell now.